Day 5. Right, so 3 members sold tickets. James sold 10 more than Bonnie. Bonnie sold twice as many as Mike. So we have to write algebraic expressions to represent how many tickets each of them sold. So let's start with James. James sells 10 more than whatever Bonnie sold. 10 plus B. Bonnie, she sold twice as many as Mike. So I'm just going to write twice whatever Mike sold. And then Mike, well, Mike just sold whatever he sold. Let's call it M. Now, notice that we have two variables here, M and a B. Now, B stands for Bonnie, so I can come over here and replace Bonnie with 2M, right? It's the same thing. So now the expression that I can use to represent what each of them, each sold in total would be 10 plus 2M plus 2M plus M, right? This is what James sold, this is what Bonnie sold, and this is what Mike sold. So the expression would be, well, I can combine like terms, so that would be 10 plus 5M. So that's part A. Part B says 290 tickets were sold, right? Using the information above, figure out how many each sold. Well, I can set up an equation. 10 plus 5M, use the expression from before, equals 295. Subtract 10 from each side, we get 5M equals 285. Divide both sides by 5, and M equals 57. So that means that Mike sold 57. Right, so I'll write here, Mike is M, so he's 57. Bonnie was twice whatever Mike sells, is 57 times 2, which is 114. And then James was 10 more than Bonnie. So Bonnie sold 114, so 10 more than that would be 124. That's how many tickets each sold. Part C says, what the heck is part C? Since party decorations and refreshments from the dance were donated, 100% of all ticket sales from the dance were there. If 295 students attended the dance at a ticket of $6, how much money did the student government make from the dance? Well, so the tickets were $6 each, 295 tickets were sold, just multiply that, right? And we should get 0, 7, then 7, 1,770. So that was just basic arithmetic. Two expressions are shown below. Apply the distributive property to write an expression that's equivalent to expression P. So if you do the distributive property here, right, careful with your signs. So it's a positive times a positive, we get a 6x, and then it's a positive times a negative, so we get negative 18. Explain whether or not expressions P and Q are equivalent for any value of x. Well, I guess they're saying, is expression P, 6x minus 18, equal to expression Q? And obviously, we can say it's no, doesn't matter. They're not equal to each other. We can tell that the expression is not the same. So, and if you want to substitute and play around, I know, make x equals 0, make x equals 2, make x equals 2. Substitute on the left side and the right side. See if you get one expression equal to the other expression, and you'll see that they're not. Okay. Now simple 3. Again, this is equivalent expressions, right? That seems to be the theme. Identify each expression as either equal to 12x plus 36y or not equal. So A, is A equal to 12x plus 36y? Well, I have to, combine like terms. Remember, there's parentheses, so pretend there's a invisible one here and invisible one. Do this distributive property. Because the outside factor is positive, everything comes out with the same sign. So that just becomes 10x plus 36y, and then if you multiply 1 times 2x and 1 times y, it comes out exactly the same, plus 2x plus y. If you combine the like terms, you get 10x and 2x, which is 12x. 36y plus y is 37y. So letter A is not equivalent, so I'll put that in that box. Letter B, again, it's 3 property, you get 12x, remember I'm doing this, 12x plus 15y, and then plus 21y. Well, combine like terms, these two are like terms, so 12x, 15 plus 21 is 36y. So letter B is equal to 36, 12x plus 36y. Letter C, 6 times 3x is 18x, and then 6 times 6 is 36y. So you can tell that's not equal, so C goes in this box. And the last one, combine like terms, we got the 5x and the x and this x. Remember, sorry, let me circle with a plus sign. So 5 plus x is 6x, plus 6 is 12x, and then 5y plus 6y is 11y. So that's definitely not equal to 12x plus 36, so D goes in this box. So that would have been your solution. 4. Olakandi is 10 inches taller than his son. Let x represent the height of Mr. Olakandi. So Mr. Olakandi is x. Write an expression in your answer to represent the height of Mr. Olakandi. So if Mr. Olakandi is x, right? Then the height of his son would be whatever Mr. Olakandi is, minus 10, right? Because I guess I'm assuming he's the dad. The dad is taller by 10 inches, right? So his son would be whatever the dad's height is, which is x minus 10. Okay. And if Mr. Olakandi is 73 inches tall, how tall is his son? Okay. So if Mr. Olakandi, let's change that, x is 73, right? The son would be 73 minus 10, 63. All right, nothing complicated there. Joe has a sales job that pays him 3%, $3,000, and here is 10%. Monthly sales as a commission can be used, write an expression to use Joe's earnings for the months. Let D represent his sales for the months in dollars. So hang on a second. So his earnings would be the $3,000, right, that he makes, plus 10% or 0.10 times whatever he sells. Okay, so that would be the expression that we use. So 1 month his total sales was $34,000. How much money did he make? Well, he takes $3,000 no matter what. Plus he takes 10% of whatever he sold. So we're going to take 10% of his sales, which was $34,000. So this particular month, he would take the $3,000. 10% of $34,000 is $3,400. His take home before taxes would be $6,800. 6. Mary wrote a sequence using the following steps. -10th as the first term, okay. Each term after that was 4 less than the immediately preceding term. So 4 less. So if the first term is -10, 4 less is not -6, right? Because that, right? So if you think about number line, here is -10. I don't know, let's make this 0. This is -20. This is +10. So if we're going less, we gotta go that way. So if the first term is -10, right? We're going to go less. 4 less, we got to go 1, 2, 3, 4, which makes the second term -14. So A and B automatically, you don't even have to worry about. So -14, so both have -10, both have -14 as the second term, which is correct. And 4 less than that would be -18, so that's good. And then 4, so 5, 15, 16, 17, 18. And then if from negative 18 you go 4 less, even 4 more units to the left, from negative 18 you actually go 19, 20, 21, 22. So the next term after that would be negative 22. So that's already incorrect. So our correct answer is letter. Okay, just be careful. Oops, less. 5, 6, 7 here. What property is being used here? Obviously, right? We've done more than enough of these. Distributive property. Multiply the outside factor, right? Distributive property says that if you multiply the outside factor times each of the factors of the terms inside, and you add them, right? You get the same expression, an equivalent expression. 8. Which exhibit explains the identity property of multiplication? Identity property of multiplication says that if you multiply by any number by 1, you get that same number. And that is our answer, letter B. Okay, so those are really fast and easy to do. That was 8, sorry. 9. Which property of real numbers illustrated below? This is still the, I guess, repetitive from what we just did. This is also the distributive property, right? X times Y plus X times D. So this is the community property of multiplication. Sorry. Take that back. Distributive property. What the heck? Apologies. 10. Which of the following is equivalent to 4x, 4 times multiplied x plus 5 minus all that. So if you do this distributive property, we get 4x. So this one has 4x, this one has 4x, and then 4 times 5, which is positive 20. So this is good, this is not, and this is good. So B and C are gone. And then it's negative 3 times x, which gives us negative 3x. So this is good, and this is good. And then negative 3 and positive 2 should give you negative 6. So this is good, and this is not good. So final answer. 11. Which of the following is equivalent to the expression below? Again, right? So negative times a positive is a negative. So my first term should be negative. That automatically disqualified this guy and this guy, right? Negative a half times 6 is negative 3, and then negative times a negative is a positive, so, and half of 8 is 4, so that leaves me with that, plus 4x, right? So if you do this distributive property, this is what you would get. 12. Distributive property is used to simplify the expression. Which of the following is the result? All right. So if we multiply these two, we get 2wx, right? And then we multiply these two, we get positive 2wy, and then minus 3z. Remember, the 2w does not multiply this, right? It's only the terms in the parentheses. So do we have anything that looks like this? 2wx, 2wy, minus 3z. There we go. 13. Tony needs to solve the equation shown below. For what operation Tony performed to solve the equation for t? Alright, so we can multiply both sides. So again, remember what this is actually saying. So 3/4 of t equals 6 over 20. The shortcut is knowing that we can multiply both sides by 4/3, right? 4/3. And do we have something like that? We don't. Good. But why do we say multiply both sides by 4/3? Let me take a step back here. So imagine an equation that says 5x equals 10. So if we did what we did in class, which used inverse operations to solve this equation, our next step here, what's the opposite of multiplication? Would be division. We divide this by 5 and this by 5, right? And that simplifies. My x is isolated, and I get the answer here. This is the same thing. So we would divide both sides, this side by 3 over 4, and divide this side by 3 over 4, right? 3/4 divided by 3/4 gets eliminated. Now, think about, and then, so if you eliminate these two, now we have the other side to deal with. That says 6 over 20 divided by 3/4. So isn't that, so when we divide fractions, don't we multiply by the reciprocal? Right, which is what I did in the beginning. We multiply both sides by the reciprocal of 3/4, which is 4/3. But in actuality, we're actually dividing both sides by 3/4, which is this. Emily is 12. She writes an equation to find her mother's age, m. So mom is minus 12 equals 35. Which operation solves the equation for m? Well, it's subtraction, so the inverse operation is addition, so we would add 12 to both sides. So there we go. 14. I know, some of these questions are pretty simple. 15, look at the equation. Which inverse operation will solve the equation? Well, so let me write it a little bigger. 2n equals 2n plus 1.4 equals 8.6. Now, what would be the order in which we do this? So if you remember doing that little story, I think we did a little story in our class. Here's my variable n. It's being multiplied by 2, and then we're adding 1.4. Right, so to isolate n, or to find out what n is, the first inverse operation I would do is the opposite of adding 1.4, which is subtracting 1.4, and then divide both sides by 2. So minus 1.4 on both sides. That goes away. This becomes a 2, 7.2. 2n is the only thing left on the left side. And then how do I isolate n? I divide that by 2 and divide that by 2. I know it's not asking for the answer, but that would be the two steps that I did. So subtract 1.4 and divide. So subtract and divide. Here we go. (16) Which of the following could be the next step in solving the equation? Well, if we were to do that particular equation, what's the first thing you would do? Well, we would get rid of the parentheses on both sides. So the first step would be to do the distributive property here. And remember, there's an invisible one here, and distributive property over here. So we would get 3x plus 6, and then 3, and then negative 1 times x is negative x, and negative 1 times positive 1 is negative 1. Is there anything that looks like that? 3x plus 6. B and D doesn't have 3x plus 6, so automatically throw that away. Now, on the right side, one of them has 3 minus x minus 1, and the other one has 3 minus x plus 1. And we know that that's incorrect. That's the correct answer. 17, what value they actually wants to solve, ask us to solve. So this is multi-step equation. So step 1, get rid of the distributive property. So there's nothing to do on the left side, so let's leave that alone. 9, and then positive 3 times p is positive 3p, and positive 3 times negative 6 is negative 18. 5p minus 1. Can I combine anything on the left side? Yeah, I can combine a 9 and a negative 18. So I'm going to get 3p, and then 9 and negative 18 is negative 9. I have variables on both sides. Remember, get rid of one of them. It doesn't matter who it is. I just told you in class. I prefer to get rid of the one with a smaller coefficient. So 3p will go. How do I get rid of it? Well, subtract 3p from that side. But if I do that on the right side, I must do it on the left side. These two go away. Negative 9 is left over. 5p minus 3p is 2p minus 1. And then from here, it's just a simple two-step equation. So what do we do here? Get line in the middle. We do plus 1 on both sides. That gets rid of the 1 for us. That goes away. Negative 9 plus 1 is negative 8. 2p comes down. We're going to divide now both sides by 2, and finally our p is isolated, and p is negative 4. I don't think it's asking us to, what do you call, check, but who knows, maybe on the state test, you have to go take that negative 4, plug it in here, right, instead of p, plug it in here, make sure that the left side equals the right side. Okay, that would be a complete problem. $17. Oh, here we go. 18. Hang on a second. Yeah, 17, 18. What is the solution to the equation? Okay, more equations. Hopefully you guys may remember how to do these. So 2/3 x plus 4. Now, what did we do here? Yes, you can just do this distributive property and deal with fractions if you like. I mean, or we can multiply and we can get rid of the fraction. Right? How do we do that? Well, we multiply both sides in this case, right? By 3. If I multiply this side by 3, again, I gotta multiply this one, this side here, you have to put it in parentheses and multiply that by 3. Right, and then that would, give me a second, let's see if I can, instead of doing that, not to complicate things. Let's do distributive property. So I get 1/3 x plus 2/3. And then over here, I don't do anything, plus 4. Now, I would multiply everything on this side by 3 and everything on this side by 3. So, if you did that, you multiply this, 3 times 1/3 is just 1x, or just x. And then you multiply this, 3 times 2/3, that 3 and the bottom 3 simplify to 1, and all you have left is 2. On the left side, 2/3 times 3, again that 3 and this bottom 3 simplifies, right? And we left with 2x, and then we just did that, and then 3 times 4 would be positive 12. And from here on, you just solve. Let's see, get rid of the x. There's 2 variables on both sides. Let's get rid of the one with a smaller coefficient, which is this one. Minus x, this goes away, 2 is left over, 2x minus x is x, plus 12, and we're going to subtract 12 from each side, and x equals, that goes away, and x equals negative 10. Alright, so again, this is not that bad. 19. What's the solution to the equation below? Okay, so again, 2 ways you can do this. Or a lot of ways you can do this. You can get rid of the fractions. And one way of doing it is to, in this case, both denominators are different, so you find a common multiple, or the lowest common multiple, which is 12, and multiply both sides by 12. So take that, multiply that by 12, and take the other side and multiply by 12. Look at what happens. 12 and 4, this will simplify to 3. I have 3x left over here. On the other side, this 12 and 3 will simplify to 4, right? And then that 4 can be used to do the distributive property. And we get 4x plus 1. And we can continue solving, right? But before, I'll just finish it. And then, let's see. Now, let's get rid of, doesn't matter if we get rid of here. Let's get rid of the one with the smaller coefficient. So we'll do minus 3x on this side, and we'll do minus 3x over here. That goes away, but in this case, we actually have to write 0 because we can't leave the left side empty, right? So 4x minus 3x is x plus 1, and now we're going to subtract 1 from both sides. That goes away. My x is all by itself, and x equals negative 1, which is b. The other way you could have done this, right, just like when we have a portion, is cross multiply. 3x, x times 3 is 3x. 4 times that, again, distributive property, you get 4x plus 4. What did I forget? Oh, shoot. This should have been a 4. Apologies. I made a mistake. This here should have been a 4. Okay, so that everything else is correct. So over here we do -4, -4. The actual answer is A. So same thing here, and if you didn't want to get rid of the fractions by multiplying both sides by the lowest common multiple, you could have cross multiplied. X times 3 is 3x, 4 times x is 4, 4 times 1 is 4. So notice that this is exactly the same as that. And then you take it and you solve the equation and you get the same answer. It's just a matter of which one you rather start with. Okay. All right. So again, not that bad, right? That was day